Hi everyone, welcome to this session from Docker to Big Data Cluster. My name is Christophe Laporte. I live in Toulouse in the southwest of France. You can reach me on Twitter or LinkedIn if you want. I'm a certified master on SQL Server and I'm also Microsoft MVP. Feel free to explore everything PASS has to offer as a webinar or in-person event. At the end of this session, please fill the evaluation form. It will help me to improve the content of this session. Thank you. In 1997, I started my journey on SQL Server. It was version 6.5. Everything was different on this old version of SQL Server. For example, you don't have a SQL Server agent, you just have the SQL executive. It was quite the same thing. But internally, the databases was very, very different. You only have a single data file to host the data and the transaction log. And to prevent some data loss, because there was not a lot of RAID system, Microsoft introduces some mirroring capabilities, and you can write the same file on two drives, physically two drives. It was very, very interesting. This functionality has disappeared. A little bit of archaeology now. SQL Server was born in 1989. It was a project to port sidebars on OS/2. At the beginning, this project was conducted by Microsoft, Ashton Tate, and Sidebars. And after that, Microsoft wishes to land SQL Server on a new platform called Windows NT, and SQL Server 4.21a was the first version to be available on this platform. A few years later, SQL Server 6.0 marked the end of the collaboration with Sybase. And in 1998, SQL Server 7.0 marked the conversion of the code from C to C++. At the end of the year 2005, SQL Server 2005 was a complete revision of the old Sybase code. SQL Server is constantly evolving, as we can see it. There are a lot of new capabilities like temporal tables, some graph databases, a lot of T-SQL improvements, for example, the over clause. There are also a lot of HADR functionalities like AlwaysOn Availability Groups, which appeared with SQL Server 2012. A lot of security improvements, because security is very, very important, and you can encrypt your data at rest on disk with a TDE, transparent data encryption, and you can also encrypt the data from your server to the computer you are using with always encrypted. Everything is encrypted on the transport level. Row-level security and dynamic data masking may help you to respect GDPR if you are concerned, and people might have access only to the data they are allowed to. You can also have some extensibility feature to reach data outside SQL Server with Polybase. You can read data from Cosmos DB, MongoDB, Teradata, Oracle, and so on. It's a kind of super linked server. You can also add some code inside SQL Server to do stuff SQL Server doesn't know to do it. You can add some .NET code with a SQL CLR, or if you prefer, you can use Java or Python or R. A lot of performance enhancement in the last version of SQL Server. For example, Hackathon, the in-memory or LTP engine, allows some log-free and latch-free workload to run very, very faster. For the BI part, the BI side, the column store index may allows you to store data in a different way. You can use the batch mode inside SQL Server, which is very, very performant. And also, you can make a very, very fast aggregation on large tables. The new cardinality estimator was introduced in SQL Server 2014, which improves some workloads. Also, the TimDB scalability has been improved using Hackathon in the latest version of SQL Server, but in the past it was a kind of behavior that prevents SQL Server to write data on disk on the TimDB data file just to save some time. The intelligent QP has also evolved with the version 2017 and 19 in SQL Server to allow fastest workload. A bit of history now. 10 years ago, I remember giving some talks about SQL Server and virtualization, and we were wondering, should I virtualize SQL Server or not? What about the performance? Is it the right choice to virtualize SQL Server? Which hypervisor should I choose? VMware, Hyper-V, maybe Xen Server, and we were very curious about that. SQL Server and the databases was the last workload to migrate to a virtualized environment. Nowadays, almost all SQL servers are virtualized on-prem, and we have very, very good performance even with the tier 1 workloads. Wow, in 2016, Microsoft announces that SQL Server will be ported on Linux. A revolution. SQL Server on Linux, some figures. Microsoft estimated that 5 years will be necessary to port SQL Server on Linux natively. And that's because there is a lot of stuff, a lot of code to review. If we look deeper at SQL Server, inside SQL Server, a very low level, there is the SQL OS. And the SQL OS is just a layer that is responsible of the memory, that is responsible of locking, scheduling, and so on. And if we think differently, we can just take everything inside the SQL OS and redirect the API calls to maybe Linux or Windows. If you are very interested on the SQL OS, I suggest that you look at the SQL Server OS 2012 session given by Bob Ward. It's very, very interesting to see how the SQL OS worked. Microsoft has chosen to think different, and they make a prototype using the SQL PAL in 3 weeks only. The goal is just to rewrite the SQL OS and to introduce another layer to be sure that API calls can be redirected on Windows or on Linux, depending on your platform. And the final release was done 24 months later. If you are very interested in the SQL PAL layer, you can look at the Inside SQL Server 2017 on Linux session from Bob Ward. It was in the past. It was at the PAS Summit 2017. Why Microsoft decided to port Linux on SQL Server on Linux? Because that's a customer wishes. Some of customers have only Linux boxes and they use Windows only for SQL Server. And also there is some expectation from ISVs. And maybe also because they want to win some market share because SQL Server wants to increase the market share. Installing SQL Server on Linux is very, very simple. It's straightforward. Depending on your flavor, Ubuntu, Red Hat, or SUSE, that's the Linux edition that are supported right now. But it does not mean that you cannot install it and it will not run on different version of Linux. You can use it on Ubuntu, Red Hat, or SUSE, and depending on your package manager, you will just have to call an apt-get install or yum install or zyper install. It's very, very simple. And at the end of the setup process, you just have to use a tool called MS-SQL conf to run the setup of SQL Server to give the SA password and so on. It just looks like that. At the end of the installation, you are just prompted to give your edition, to accept the license term, and after to give a SA password. Very, very simple. The performance are very, very good. Some testing have been made. The TPC organization also have made some testing, and the performance of SQL Server on Linux is very, very impressive. Feel free to try that. If we are looking now to the application layer, microservices, yesterday when I start working on development and so on, there was some monolithic application. I start working with the COBOL programming, and it was very, very hard to maintain and to make this environment to evolve. Everything was inside a single program, and I remember asking for a compile batch at the end of the day, and the next day we've got a large listing with all the mistakes we have made. It was terrific. It's very, very hard to maintain a monolithic application. Today, we are talking about microservices. It's a new way to develop application. It's very lightweight piece of software that can evolve independently. For example, you can make the payment application to evolve without redesigning or retesting the driver management or the passenger web UI in your application. That's very, very interesting because many teams can collaborate to work on the same project. Very, very easy. And an application is just a bunch of containers. Maybe 1, 10, or maybe 100 containers can compose a single application. It seems to become a standard from an infrastructure perspective, but also from a DevOps philosophy. Container for DBAs, we are talking about virtualization. The first virtualization was hardware virtualization with Hyper-V or VMware. And you've got some virtual machine over an hypervisor, which relies on an operating system and on the hardware. For containers, we are talking about the second version of virtualization. It's known as containerization. It's just an OS virtualization. And as you can see it, there is no more OS guest. There is no more guest OS on my hardware. You just have the operating system and the container runtime. After, you can plug a lot of containers using the DLAs, the library from the underlying operating system. There is some isolation. A container is not visible from the network. You can reach the host, and the host will make some NATing to connect you to the correct container. A container is stateless. That means that when you stop and remove the container, everything is lost. Okay. Some terminology now. An image. An image is just a read-only template with instruction for creating the container. And the container is just a runnable instance of an image, totally isolated from the surrounding. Good. Let's move on. So, containerization, a very, very small footprint. There is a better efficiency than using virtualization with VMs. A single image can be deployed on the development infrastructure, the test, and the production. And it avoids the mistake it works on my computer when I developed the software, but it does not work on production. That's impossible when using images. It will always run the same, regardless of where it is deployed, on-prem, in the cloud. It's exactly the same. And the deployment is very, very, very fast. Docker seems to be the leader of the market, even if there is some alternative like Podman, Mesos, or LXC or LKT, which we can pronounce Rocket. Docker is first an engine, which is responsible for container execution. And after, you've got a client, a command line utility, just to instruct Docker what he has to do, to run a container, or just to build a new container, build a new image, or you can pull image from a repository, for example, the Docker Hub. Docker is a multi-OS platform. You can install it on Windows or Mac or Linux. You will always have the same command line, regardless where you are running it. Exactly the same behavior. If you are a Windows guy, you can install Docker for Windows. It's very easy to set up. If you prefer Linux, you can install it on Linux if you want, with a simple command line. What are the simplest command and the very first command you will use using Docker? Docker pull. You can download an image from the repository on your local machine, on your host, and after you can run the container. You can run the container by using Docker start. It will start the container, or you can use Docker run. Docker run will automatically pull the container, create the container, and after that, start the container. After that, you can stop or remove the container if you want. Let's have a little demo about containers. I'm going to connect to a Linux box. It's an Ubuntu. And on this machine, Docker is installed. You can see that Docker version 19.03.13 is installed on my machine. I can run the simple command docker run hello world. This command will just download the image of the container, and after that start the container, and after it exists. And we can see that it succeeds because I've got the message hello from Docker. We can also download some more complex image. For example, we can download, and it is very fast, an Ubuntu image. It downloads the image on my machine, and after docker run -it, an interactive prompt is open inside my container, and I can see here that I am connected as root inside this Ubuntu container. Right? I can exit my container. I'm back on my host machine, and I can see all the container that is actually running. None of them. But I can also see all the container that have exited. And I can see here that my Ubuntu container and my Hello World container are ended. Let's switch back to the presentation. Wait, we can run SQL Server on Linux. That was a new OS? Not really an accomplishment. A new OS, in the past, SQL Server was a Sybase derived, and it was running on OS2. But yes, Linux is, that's a new OS. I'm not sure that's an accomplishment, because I think that's just the beginning of a new chapter for SQL Server. So, why not running it in a container? Running on Linux was a mandatory milestone for containerization. And we need some extra stuff to make SQL Server run properly on Docker. First, TCP port redirection, because remember, a container is fully isolated from the surrounding. So I cannot see the container running inside my Docker from my own computer. So I just need to connect the host, and after that, the host will redirect me on the right TCP port inside the container. And I need some redirection for the volume because I need some persistent storage. If you create a SQL Server container, you stop it, you remove it, you have lost everything inside your container. But if you use some volume redirection, you are able to stop your container, to remove your container, and after that you can spin up a new one using the same persistent storage, and you will find all your databases. That's very, very interesting. Let's make a demo about that. All the code will be available for download on my GitHub and on the PASS Summit website. I will connect to the Ubuntu machine. I am already on the Ubuntu machine. I can see the list of all SQL Server version available for Docker. You can see that there is a SQL Server 2017 with the different cumulative updates, and also SQL Server 2019. You can download a specific version of the Microsoft SQL Server from the Microsoft repository. And if you want to see everything, all the image you have downloaded, sudo docker images, you can see that I have already downloaded the SQL Server 2019 cumulative update 8 and 6 for SQL Server. Please note that cumulative update 8 is the same version than the latest version of SQL Server. If I just want to run my SQL Server inside Docker, I will use the docker run command. I will launch that. It just spin off a container and that's done. I have given a name and a host name for my container. I have given some environment variables like the edition of SQL Server, the SA password. We are asked to accept the license term, and there is the volume redirection. The /MSSQL on my host machine will host all the file for the MSSQL/data folder inside the container. And as after, I will publish the port 1433 just to be able to connect to my SQL Server. I can see some information about my container, and I just see the error log of SQL Server, which is pushed in the output of the container. I can connect to my container using SQL CMD, and I'm reaching my host machine using the redirected TCP port. And I am with SQL Server 2019 CU6. I can see the list of the database if I want. I can also connect inside my container using the docker exec. I will be connected inside my container using the bash shell. I am inside my container, and I can also connect to SQL Server to maybe create a database and list the database. I see my database inside the container. I can also see all the files inside my container, but if I exit my container, I can stop my container, I can remove my container, and I still have all the files on my host machine. It means that I can run my container again with the same volume redirection and just change the cumulative update of SQL Server to make an upgrade, for example. My container has been up. I can see, it does not spin up yet. Just have to wait a little bit. I'm not sure the upgrade is finished. Yes, I cannot connect yet because the upgrade has not finished. but it will be available in a few seconds, depending on the power, the number of CPU of your machine. Yes, that's done. Database master is upgrading, and so on and so on. And you see the typical script when SQL Server is upgrading from a cumulative update to another, or maybe when you are applying some service pack in the past. Cumulative update, upgrade, and downgrade are possible. Okay. Okay, that's not finished yet, but feel free to believe me, it works. You can try that if you want. I said you that spinning up some containers was very fast, and I can prove that with running multiple containers at once, and you will see how fast is it to spin multiple containers. That's okay. All my containers are now up and running with the latest version of SQL Server 2019. It's not possible to run some virtual machine with SQL Server as fast as I can start my containers. Very interesting. I can exit from my host, and if the upgrade of SQL Server cumulative update is finished, I will be able to connect. That's finished. Yes, I see my database inside the SQL Server Docker container. Very interesting. If you just want to remove all your container and to stop your container, you can use such a script. Okay, let's move on. Sorry, wrong password. We'll see that afterwards. Now, what's next? We need some orchestration for containers, because if the host is not healthy, we have to restart the container on another host. Or if the container is not healthy, we have to restart the container somewhere. We must provide some network access to the container and provide some persistent storage across multiple nodes. Oh, that's a cluster. No? Yes, that's a cluster. We need a cluster to host our containers. And we also need some scaling function to manage container resources like CPU, RAM. We can limit the CPU, we can limit the RAM that the container will be able to use. And also we need some scaling functionalities, maybe by adding more containers. That's not possible for SQL Server because SQL Server is stateful, but let's imagine that you have some containers with web servers, for example. You can spin up multiple containers and just use the orchestration level to scale out on all the web servers. We wish a similar deployment experience if we are on-prem or on a public cloud. The main actors of the market right now are Docker Swarm, Kubernetes, if you are looking of the cloud side, or if you are on-prem, maybe OpenShift is a right choice today. OpenShift, by Red Hat. We will just have a look to Kubernetes because Kubernetes seems to have won the market actually. Kubernetes for DBAs. Maybe you have seen K8s just because there was too much letters inside Kubernetes and it's faster to say there is a K, there is 8 letters, and there is a S at the end. When we are talking about Kubernetes, we are talking about pod. We are not talking about containers. A pod is the smallest management unit for Kubernetes. And this smallest management unit may contain maybe many containers. A pod is made of one or n containers. And each pod has a unique IP address inside the Kubernetes cluster. Okay. There is a master node, which is responsible for port scheduling on different worker nodes. The worker nodes are also known as minion. A worker node is just a node hosting Kubernetes and a runtime to be able to run the container, the pod. So the kubelet is just responsible for running a container. That's a small piece of software that is responsible to run a container. It is asked from the Kubernetes control layer, the master node, to run a specific container. And the kube-proxy is just some network traffic manager, because you can connect any node on the cluster, you will be redirected to the correct pod inside the cluster, even if it's not the correct host. Kubernetes works with the desired state configuration, which means that you are asking for Kubernetes to maintain one pod using SQL Server. And if this pod has an issue, if it's crashing, then Kubernetes will start again this pod somewhere. We are able to connect to the application with the kube-proxy, as said before. The kube-proxy will make some routing and netting to the pod inside the cluster, no matter the worker node where your pod is running. And you are connecting through services. Services exposes application. An application is just a logical abstraction of one or more pods. There are different types of services. The first one, the cluster IP. You can only use this kind of service when you are inside the Kubernetes cluster. Imagine you are using one application, and this application needs to connect to another application inside the cluster, the Kubernetes cluster. You can use a cluster IP service. For example, there is an IT, the web port for my application, and the cluster IP will automatically scale out the traffic, load balance the traffic between a certain number of pods inside your cluster, depending on your scale set. You can use the node port, and right now you can reach your application from outside the Kubernetes cluster. You have a specific range TCP port to connect on the cluster, and whatever the node you are connecting, you can reach your application. And once more, the node port will load balance the traffic on every pod that is able to manage your workload. And the last one, the load balancer, and we are going to use this one because we are going to use it on Azure. The load balancer will load balance the incoming traffic from outside the cluster onto different nodes, and these nodes will redirect on the pod that are inside your application. The command line utility, kubectl or kubecontrol, depending of how you want to say that. Kubectl apply with the file, and you are going to create some resources. Resources can be a load balancer, can be some storage, can be an application, a deployment for SQL Server, for example. You can delete the resource, or you can just run a single image from something, for example, Nginx. Kubectl get pods, list all the pod on my instance. Kubectl get services, list all the services I can connect to with the IP address, and the deployment and the nodes and so on and so on. And if you want to connect inside a specific container, you can do it using the kubectl exec-it, an interactive with the pod name, and after you are launching some batch command, for example. A bit of history again. 10 years ago, we were wondering, should I virtualize SQL Server? Is it the right choice? And so on. And at the same time, Microsoft was releasing some cloud services. Not the same name as actually, because it was Windows Azure platform, but that's exactly the same thing. And when Windows Azure platform was launched, there was a few services with virtual machine, with storage, and there was SQL Server at the first release of the Windows Azure platform. If we are looking now on SQL Server on Azure, we can use it on virtual machine. Very, very easy to make some migration, lift and shift. If you need to have some OS level access, you definitively have to use some virtual machine for your SQL Server on Azure. If you don't care about the OS level, but you want to have some cross databases operation, for example, managed instance is very, very interesting. That's a PaaS service, but you can use multiple database, and the database can be are hosted on the same SQL server, and you can make some cross databases, for example. And after, you've got some Azure SQL databases. That's the PaaS service, and the granularity is one database. So if you just want to deploy one database, you can use this PaaS service. But if you are looking on containers on Azure, there is two flavors. The first one, Azure Container Instances, and the second one, Azure Kubernetes Services. The first one, ACI, that's very, very easy to spin up a container without managing Kubernetes, the server, and so on. You don't care about that. You just want to have one container running for a certain time. And you will be charged for every gigabyte and every second of CPU you are consuming. It's very interesting to use ACI for DevOps scenario. You spin up a new container with SQL Server, you make your testing, and after that you shut down your container. But I'm not sure that's very, very interesting for long duration workload, because you don't have access easily to the persistent storage. You have to find some tricks to use some persistent storage using ACI. If you want, you can just try it using this kind of script. You can create an ACI container using the iz container create and all the parameters after. AKS, that's a fully managed cluster on Azure, a Kubernetes cluster managed for you. You don't have to do anything. All the storage is provided, all the network is configured, all Kubernetes configuration is made for the master node and the minion and so on. You just have to launch one command to create the cluster. Very, very easy. You define the number of nodes inside the cluster, the version of Kubernetes, and that's all. But you have to maintain the cluster. If you want to upgrade Kubernetes, you have to do it. And if the version you are using is no more supported, you have to update your cluster. You are charged for the virtual machine associated with your cluster and for all the storage and the networking resources that are consumed. That's really suitable for production environment. Because HA is enabled by default for your SQL Server instance inside Kubernetes. Remember, we have some persistent volume that can take all your data files, and Kubernetes is responsible to maintain a desired state configuration. That means that if something occurs on one pod, there will be some kind of failover, an automatic failover. The pod will be recreated, maybe on the same volume, maybe on another volume. But for your application, your website, or whatever your application is, your application will just reconnect to the same IP address because the service object has not changed. The pod has changed from one node to another node, or depend of what the issue was. But your application will be redirected to the new created pod. We'll have a demo about deploying SQL Server on Kubernetes. I am on my machine and clear. Let's run that. I have a cluster with 3 nodes. You can see that the 3 nodes are aged for 8 days now. We can see all the deployment that are made, all the pod, the persistent volume. Persistent volume and persistent volume claims is just some storage provided to your Kubernetes cluster. You've got some namespace just to be sure that you cannot melt one application and another application and focus on one specific application. Okay, there is some multiple namespace right now. I can create my own namespace inside my Kubernetes cluster, and I can see it again, past summit 2020. I will just split my screen, and we can use kubectl get all the resources inside the namespace past summit. And right now there is no resources inside my Kubernetes namespace. I can create a secret, very useful, just to be sure that just one time I see my SA password, and every time I need to spin up a container or something like that, I can use my secret. A secret is just an abstraction for something you want to hide to developers, for example. I'm creating my secret. I can deploy very easily my SQL Server instance inside my Kubernetes cluster using a single YAML file. And my YAML file, we will see that after in a while. It's just some storage, persistent volume claim, and after I've got my SQL Server deployment. You can see the kind deployment, and my deployment is based on a container with Microsoft SQL Server 2019 Cumulative Update 8. And after there is some container port, the environment variables, and the volume or redirection we are using. The next section is the service. The service is a load balancer, which allows me to connect to port 4033. So I can run a kubectl apply and with all the instruction inside, and it will create my SQL Server instance. Or I can create it independently if I want. That's exactly the same thing. I can create my load balancer. My load balancer is created, and I see that my external IP, okay, has come. I can create my storage. And after, I can deploy SQL Server. I just have to wait a while. And after that, you can see that my deployment is almost ready because I don't have the container created. It is still creating. And when this container has been created, the deployment will be ready with one container on one. Remember the desired state. That's okay. My container is running. My desired state is done. I can see my deployment and so on and so on. I can describe my pod if I want. But the most interesting is just to connect to SQL Server and launch some T-SQL commands. Oh, that's not the right IP. I'm sorry about that. And paste F8. And I am connected on my SQL Server inside a pod inside my Kubernetes cluster. And I can create a highly critical database. And this database is protected because there is automatic failover for my pod. If my pod crashes, I can recreate it on another pod. I can also connect to the pod and then submit some specific queries if you want. Remember, desired state configuration. That means that if I'm deleting my pod, let's grab the correct name of my pod. If I'm deleting my pod, it will be automatically recreated. Just look at this side of the screen. You will see that the first pod will be terminating and a new one will be spin up. That's not the correct one. Yes, because I forgot this. In a few seconds, I will see that my first pod is terminating and the second one is still running. So it's very, very fast. Right now, I can connect to the correct IP and I will see that my pod is up and running. I see my highly critical database. Even if my pod crashes, I still have access to my database. It just takes a second to spin up a new one. I can connect and to my instance. I can make some cleanup with the delete instruction. I can delete everything, or I can just delete the deployment. That means I can just delete SQL Server. I'm deleting SQL Server. The pod is terminating, and I just have the load balancer. If I recreate my deployment, the external IP has not changed, so the new SQL Server instances will be spin up using the same IP address, but I lost my database because I delete all the storage of my pod. Let's move on. We have seen that it's possible to host SQL Server inside a pod, but are we able to run an AlwaysOn Availability Group cluster inside Kubernetes? It was possible in the first release of SQL Server 2019. In the first release, it was the CTP version. But right now, on the RTM version of SQL Server, sorry, that's not available. We are all hoping that everything will be available in the few months, maybe in a cumulative update or maybe on the next release of SQL Server. Very interesting to have a Kubernetes, an always-on availability group inside Kubernetes, just because there will be two services, one for the read-write connection and one for the read-only connection. Wait. Kubernetes can run SQL Server, and SQL Server is just more than a database today because we have Polybase, and with Polybase we can access some external data like NoSQL databases, Cosmos DB or MongoDB, but also some databases like SAP, IBM DB2, MySQL, Postgre, Teradata, and so on. But we can also add some external data for big data like Spark or Hortonworks or Cloudera. Kubernetes can host a lot of kind of application, and Microsoft said that a few years ago in a blog post. You have the link in the back in the bottom of the screen, and Microsoft said that Microsoft and Docker or Microsoft and container can handle almost 98% of workload. That means that containerization will be the future of infrastructure. But all kind of application, that's interesting. And pods can host multiple containers. We have seen that a pod can be made of one or n containers. So we can add some big data containers inside my pod with, for example, a Spark engine and some AGFS storage. Yes, right. That's big data cluster. SQL Server 2019 big data cluster is just a lot of piece of software managed by Kubernetes. And all this piece of software allows me to connect using my traditional T-SQL tools, Management Studio, Azure Data Studio, SQL CMD, and I can run some workload inside this big data cluster using some HDFS storage and some external data and so on. Very interesting. There is a control plane, and the control plane is just a set of pods for administration and monitoring and so on. And there are a lot of pods involved in the monitoring of SQL Server. You can see on my back there is some Grafana screens showing the actual state of my Kubernetes cluster, my big data cluster. The SQL Server master instance, that's the only SQL Server we connect directly. We are going to run all our queries on this SQL Server instance. And this instance will be responsible for running small queries. All other stuff will be offloaded onto the compute pool and the data pool. The compute pool, that's SQL Server instances. And these instances provide some compute resources for distributed queries. And the distributed queries are just maybe joining some multiple directories in HDFS storage, or maybe joining some tables from Oracle and MongoDB, or Teradata and MySQL, as you want. The compute pool is just a layer that looks like Polybase scale-out groups if you used it in the past. The storage pool. The storage pool is the kind of magic because you've got a SQL Server storage instance that is responsible just to communicate with the Spark engine to execute some queries. And this SQL Server instance will just use some open rosette queries to ask Spark to make some stuff at the storage level on HDFS. The data plane. The data pool is a set of SQL Server instances that provide some storage and compute for the master data instance. It's used for computing some complex query join and offloading some analytic query execution from the master instance. When we are going to create a sample database inside the big data cluster, it will take some time. And because it creates a lot of things on the different layer of the big data cluster. And when we are going to create some external tables using Polybase, there are a lot of things created inside the data pool. Yes, the big data cluster is very, very complex and everything relies on Kubernetes. If you want to see all that is created by the big data cluster, we can just have the look on all the resources created for the Kubernetes cluster and the big data cluster. You've got a lot of disk and so on and so on. Let's play with the big data cluster right now. I'm going to use Azure Data Studio to connect to my big data cluster, and you see that you can have some specific extension for the big data cluster, and you can connect to a bunch of IP address for the master instance. That's the SQL Server IP address and a TCP port that I will be granted to connect, and the only one I will be granted to connect. And after, you have some metric dashboard with the Grafana or log search as dashboard for debugging using Kibana. If you just want to see that in detail, that's the metrics I can have using the big data cluster. That's the default metrics that are provided by Microsoft. There are a lot of containers that are monitoring my Kubernetes cluster. If you want to see that, we can just make a small pods F8. That's all the pod involved in my MS SQL cluster. That's my big data cluster. That's all the pods involved in my big data cluster. I will connect to the big data cluster using the Azure Data Studio, and you can see that I am already connected with the default databases and some HDFS storage. I have already uploaded some files to make some demonstration. Refresh. Maybe there's some issue on the refresh. Okay, my file. Okay, my file are here. That's some sample files that I have uploaded. I can connect to my big data cluster using the T-SQL kernel, and I'm running a simple data query just to see that my SQL is running a 2019 version with the RTM cumulative update. I can create a database, and it will take some time to create a database because remember there are a lot of SQL Server instances inside my big data cluster. When it's done, I will just create an external data source that points to my storage, my HDFS storage. Next, I can create an external file format just to describe this file. I can see it doesn't want to preview. It doesn't want to see the file. Okay, I can see the file somewhere else. Data. And I can see it. That's just some CSV file hosting some weather station data. That's done. And after that, I will create an external table with all the columns reflecting the structure of my CSV file. File format was not created. Sorry about that. Command successful. And now I can just run some queries inside SQL Server, and the query lasts sometimes just because that's the first time, but I can select all the data from my CSV file inside SQL Server with a simple T-SQL command. I can switch now on another engine, Spark. I'm not a data scientist, but many of them used to use some Python script and so on. That's possible with big data cluster. And you see that the session for this notebook start momentarily. Sometimes it takes a while to start the engine because I don't provide a very, very powerful Spark engine. Maximum PySpark, come on. It will be a good idea that my big data cluster works. Maybe if I'm waiting for a while, let's switch back to SQL. SQL is running fine. Come on, yes. And if I'm going back to the Spark engine. All the file, the notebook file, okay. All the notebook and the demo file will be available. So feel free to download them and to play with that. The good thing with Azure Data Studio is that when something is wrong, it retains the old data when I used this presentation before. And you can use the dot count to see how many rows there is in the data frame. You can use the show command to see all the data. You can limit the number, but we can add some filter with simple command, the greater than, and also you can make some multiple filters. You can use a specific view just to take the temperature and the humidity and to take the summary. It will calculate for you the count, the mean, the minimum, maximum, and the maximum, and so on. If you prefer some T-SQL-like syntax, that's okay, you can use it. Just because you can use some kind of view and make some select star from your view. You can use the limit statement. That's not SQL Server statement, but it works. And you can use some min and max, average, and even the overclose, the windowing function inside SQL Server. It is available on Spark on Big Data Cluster. So feel free to play with that. All the demonstration file will be available. You can read one file or many files. That's the power of the Big Data Cluster and HDFS. Let's switch back to the presentation. SQL Server has really entered a new area. SQL Server is constantly evolving. There are new features, new capabilities. That's now a multi-platform with Windows, Linux, Docker, and even Kubernetes. And SQL Server has also a new architecture. If you are looking to hyperscale on SQL Azure, that's very interesting because this architecture made an automatic scale out on the storage and on the compute. And maybe that's the future of SQL Server because it breaks the monolithic application, the monolithic SQL engine in several microservices. That's very, very interesting. And that's the future of SQL Server. Since SQL Server has arrived on Linux, that was an achievement, that was a milestone. SQL Server has entered the container and the Kubernetes environment, and now that's really a new era for SQL Server. Thanks for attending this session. Please don't forget to fill the evaluation form. It will help me to improve this session. Thanks.